All right, L plus M give you Q and R. Okay. Which of the following information cannot be deduced from the graph? Okay. If you look at this question, you actually know. I'm just gonna write this down first. L plus M give you Q and R. Okay. And you have one more of this, 1, 1. Okay, this is moles, ICE. All right, ICE. So they told you the R was present at intervals where the experiment was repeated at the same pressure but at 700. Okay, it means there are two graphs here. All right, okay. You can see that, say I use the first experiment. Let's say I use the first experiment 1. I call this experiment 2. You know that the final amount of R is actually 0.7, okay? So I put 0.7 plus 0.7 plus 0.7 minus plus 0.7 minus 0.7 minus 0.7. So you can see that I have all the equilibrium values. If I have all the equilibrium values, right, I can actually calculate the KP. All right, I have all the equilibrium values. I can calculate the KP, all right, quite easily. Okay, why is that so? Because the question says it reacted at constant pressure. So pressure didn't change. So you can do this. You can find the partial pressure of L equilibrium, which is actually 0.3. The number moles over the total moles, which is 2. Add up together, everything is 2. So over 2 times the pressure that you know, a constant pressure, right? So you can get this value. You can find the value, you can find the partial pressure for all the gases. Definitely you can find the KP. All right, this one is true. This one, so I say which one cannot, right? I say this one can be determined. The forward reaction is exothermic. How do you know the forward reaction is exothermic? So let's see. When you increase temperature, can see when you increase temperature 350 to 700, the percentage or the amount of R actually decreases. Okay, actually decreases. So if R decreases, means the position of equilibrium actually shifts left. Okay, that's why the R actually dropped. Okay, see that? So increased temperature will favor endo. So going backwards is endo, forward is exo. So forward reaction is endo, exothermic. Yes, you can actually determine. Yep. The activation energy of the forward reaction is high. In fact, there's nothing mentioned about activation energy. This is the one that you cannot deduce. All right. Equilibrium is achieved at a faster rate at high temperature. Yes, because of higher temperature always result in a faster rate of reaction. Yeah, so this one is definitely true. Can. All right, so answer is C.